Two fan datasheets can both say 1000 cubic meters per hour and still describe completely different machines. One may reach the number only at free air, the other may deliver useful flow against system resistance. A headline maximum is not a buying answer. Before comparing brands or prices, turn each datasheet into the same question: what will this exact fan deliver at my required operating point, under my actual electrical, acoustic, environmental, and installation constraints? Start with identity, because one changed suffix can change the motor, voltage, speed, connector, bearing, or control method. Lock the complete model code, revision date, size, impeller direction, motor type, phase, frequency, and any option code. Then circle every unit. Cubic meters per hour is not cubic meters per second, pascals are not millimeters of water, input watts are not necessarily motor output watts. If the quotation and datasheet do not identify the same configuration, stop the comparison. Next, write the duty point before reading the curve, required airflow plus the pressure the fan must overcome. On a graph, airflow belongs on the horizontal axis and pressure on the vertical axis. The fan curve falls as flow increases, the system curve rises roughly with flow squared for a fixed system. Their intersection is the expected operating point. Maximum airflow and maximum pressure sit at opposite ends of the curve, so adding those two headline numbers creates a fan that does not exist. Now check which pressure the curve uses. Fan static pressure excludes outlet velocity pressure, fan total pressure includes it. Either can be valid, but the required system pressure and the selected fan curve must use compatible definitions. Also verify axis units and whether the curve shows one speed or several. In the Longwell curve example on screen, the model, speed, pascals, and cubic meters per hour stay visible because removing that context would turn a real result into a misleading generic promise. A laboratory curve is also a statement of test conditions. Look for air density, inlet temperature, altitude or barometric reference, test arrangement, speed, and whether the inlet and outlet were unobstructed. ISO 5801 provides standardized airway methods and bounded conversion rules. Installed systems can still lose performance through poor inlets, elbows, guards, filters, or discharge blockage. Never correct a curve by intuition. Ask the supplier for a documented selection at the stated conditions and flag system effects separately. Then audit the electrical row. Confirm voltage range, phase, frequency, rated speed, input power, current, power factor where stated, and the required controller or capacitor. Input power is what the fan assembly draws, motor output is mechanical shaft power. They are not interchangeable. Check whether current and power are nominal, maximum, or tied to one operating point. Finally, size the upstream supply, protection, cable, and controls from the approved technical documentation, not from a neighboring model in the series. Efficiency is meaningful only when its boundary and operating point are clear. Static efficiency and total efficiency use different pressure terms. Motor efficiency alone is not fan system efficiency. Put power, flow, pressure, and speed on the same point of the same curve. Then check whether the motor remains within its load and temperature limits across the intended control range. A fan with the highest peak efficiency may be the wrong choice if your duty point lies far from that peak or inside an unstable region. Noise needs its own translation. Sound power describes energy emitted by the source, sound pressure is what a microphone measures at a location. A dB or dB, a value without the quantity, distance, room condition, inlet or outlet side, speed, and operating point cannot support a fair comparison. Look for octave band data when tonal noise matters. Also remember that ducts, grills, turbulence, structure-borne vibration, and installation geometry can change what people hear even when the laboratory fan data is correct. Environmental limits are not footnotes. Check permitted ambient and airstream temperature, humidity or condensation limits, ingress protection rating, insulation class, duty cycle, bearing statement, mounting orientation, and any corrosion or hazardous area requirement. These labels describe different boundaries, one does not automatically substitute for another. If expected life is quoted, ask for the temperature, speed, load, duty cycle, and failure criterion behind it. Reliability claims without conditions are not selection data. Move to the dimensional drawing before approving the part number. Verify overall envelope, inlet and outlet geometry, hole pattern, shaft or impeller position, airflow and rotation arrows, cable exit, connector clearance, service access, mass, units, and tolerances. A nominal diameter is not an interchangeability guarantee. Overlay the supplier drawing on the available installation space, then mark every interface that must match. The Clean EC fan image on screen gives physical context. The drawing, not the photograph, controls fit. Controls and compliance are the final identity check. Confirm whether the exact configuration accepts 0 to 10 volt, PWM, relay, tachometer, alarm, Modbus, or another interface. Record signal ranges, reference ground, isolation, default state, and required wiring document. Treat marks and certificates the same way. Verify the exact model, configuration, standard, market, and validity scope. A logo on a catalog page is not proof that every option in a product family carries identical approval. Before requesting a final quotation, send a one-page selection brief: exact airflow and static or total pressure, air conditions, voltage and frequency, control method, installation type, dimensional interfaces, acoustic target and measurement basis, environment, compliance market, quantity, and evidence required. Ask the supplier to return the selected model, curve point, speed, input power, current, efficiency definition, sound data basis, drawing revision, and declared exceptions. Compare normalized operating points, not headline maxima. That is how a datasheet becomes a purchasing decision instead of a brochure.